So that's it for the housekeeping to kick in today's content. So thanks for joining. I'm really excited to bring you through how you can recognize value on the AWS platform. And once you have workloads running, how you can look at cost optimizing them so you have the most efficient workloads running possible. My name is John Janes. I'm one of the account managers and I'm based here in Sydney, Australia. I joined AWS about 2 years ago, and during that time I've helped a number of different enterprises, startups, and small and medium-sized businesses cost optimize their AWS footprint. Also joining me today is Paul Wakeford from Fairfax Media.
Hi, John.
Thanks, Paul. Paul's one of the cloud design, security, and cost architects there, and he's going to give us some valuable insight on his journey through cost optimization and his experiences at Fairfax. So that'll wrap up today's discussion, which will add a lot of value to see how customers practice and then actually implement these practices in the field. So just to summarize again the content, I'm going to go through the value that the AWS cloud can provide to your organization. And then once you have workloads running, then really how do you cost optimize them? So cost optimization to me comes in a number of different steps. The first one is establishing visibility on what you're running. After you have established visibility and you have workloads on the platform, what the AWS team wants to do is help work with you to that, make sure that you optimize them, and then you save cost and streamline the services that you have running. And as I mentioned, we'll have Paul, and then we'll have a quick wrap up. So I want to get into the meat of the discussion, but first, I just want to talk about a little of the value and where AWS helps customers save costs for IT workloads that they run. So AWS and the cloud for a lot of organizations is a new normal place to deploy IT workloads. And the reason that is, as an analogy, it's IT in the cloud now is similar to the Industrial Revolution, where we had a shift to on-demand power. The power of AWS and what it provides is it's provided organizations a shift to on-demand computing. So within AWS, we define the cloud as the on-demand delivery of IT resources via the internet. And when you use those resources, you're just charged consumption for what you use. So it's a pay-as-you-go model. And effectively, where organizations find value is that you're paying for fewer things. So when you're running workloads on the AWS platform, you don't have to worry about traditional on-premise costs. Those things could include some costs around real estate or even the administration and the labor associated with racking and stacking infrastructure. In AWS, we look at basic optimization as going from on-prem to running workloads in the AWS cloud. Typically, we see customers save between 20 and 40% by moving to AWS EC2 and other services such as S3 or EBS. Further along the optimization path and where AWS helps customers cost optimize is even going down new and emerging technologies around serverless. And when we look at migrating workloads and if you're taking advantage of serverless features, we've seen customers save up to 90%. I'm going to run through a number of these different patterns, and that's really today is how you can leverage these different services and what mechanisms you can do to cost optimize. AWS follows a flywheel pricing philosophy, and this is where a lot of customers find value and is how we structure our prices. So as the AWS platform grows, the incremental cost of IT infrastructure for us decreases, and we're consistently then passing these cost decreases onto our customer base. So if you've been a customer with AWS over time, you might have seen price reductions on the platform. I actually think this slide is potentially outdated. I don't know if it includes the latest price drop we had, but as of the beginning of last week, it was 66, but there were some changes recently. So we're consistently passing on price reductions to our customer base, helping them have the most cost-efficient AWS consumption. Outside of cost savings, where AWS also assists customers is in areas such as staff productivity, operational resilience, and business agility. With AWS in the cloud, you can now provision IT resources on demand. So there's no need to have a long procurement cycle in regards to procuring infrastructure or servers and racking and stacking. You can just procure an IT resource like an EC2 instance or virtual infrastructure in a number of minutes, and then get that online and run experimentation and new workloads with it. So those are just some of the values of running things on the AWS platform and how it helps in cost. So getting into this cost optimization journey, so we've talked about the value of the AWS platform. Once you have things running on the cloud, how do you look at cost optimizing them? The first area that you need to look at cost optimization is establishing good visibility. So when we look at workloads on AWS, particularly when we're moving from traditional environments to new cloud or hyperscale environments, there's new requirements for monitoring. These new requirements come from increased speed that the AWS platform provides and new services and new features that you can take advantage of. And in order to take advantage of these and to optimize, you need to get a good footprint on what costs you're incurring. So I want to run through these mechanisms, so how you can get visibility into your AWS costs. And then once you have visibility, I'll give you 5 pillars that you can use this visibility to optimize around. So the first area that you can take advantage to get good visibility into your costs is through your AWS monthly invoice. You probably have seen this if you're an AWS user today, but if you're not, at the end of every month, we consolidate AWS consumption in regards to what services, how much you use those services, and their unit cost, and we provide that to you in your invoice. This is a great step for customers just getting on the platform to see what the level of consumption is. But if you want to cost optimize, there's a lot of additional mechanisms that you can use that will assist you. The primary two, and I'm going to run through lots of examples of these over the next 40 minutes, is your AWS Billing Console and the AWS Cost Explorer. So the Billing Console is the default billing area where you can see this month's incurred charges, and then also a projected cost for the rest of their month. Where you'll want to take advantage and look at where you can optimize is in your Cost Explorer. So with your Cost Explorer, you can break out different service costs. If we're talking about EC2, you can break out different instance or family costs. And through those, you can get a lot of insight to understand where costs are being incurred within your usage, and then you can look at optimizing that cost. The fourth point, we also offer finer granularity. So if you want, you can even take advantage of your detailed billing file. And with that, you can produce do-it-yourself dashboards or implement third-party tools to help with cost visibility. So I'll give you a number of these throughout the discussion today. As you move left to right within those 4 different mechanisms, typically we see customers as the complexity of their environment, or if they're running production or large-scale environments, you might move to the more detailed information because you'll need detailed information on your AWS consumption. So after we've gotten that granularity and that visibility into what your costs are, the next step is to optimize those costs. And this is the key areas, if you're gonna look at any of the content that I'll discuss today, is these 5 pillars in regards to optimization. So the first pillar in optimization is right-sizing and decommissioning unused resources. We'll talk about how you can run things on the AWS platform at high utilization. Increasing elasticity, or effectively turning things on and off, is a great mechanism. I'll run you through how you can save up to 75% on your compute costs using reserved instances. How you can potentially look at different storage tiers and different storage options to meet your workload requirements and save costs in regards to storage. And then I'll discuss how you can work collectively with AWS, or how you can take some design principles internally to design your application and workloads for best practice in regards to costs going forward. So we'll run through some of those design patterns. So starting off and getting into the meat of things, looking at the first pillar, which is right-sizing the instances and resources that you have on the AWS platform. So right-sizing in AWS really refers to running the cheapest instances that meet the capacity requirements that you have. In a traditional IT environment, what we saw is you'd grow into infrastructure over, for example, a 12 or a 36-month term, and you would have headroom or unused capacity in the environment, which you would grow into. What I would highly encourage customers to do is look at right-sizing instances so you meet as closely as possible to the capacity that you require and the capacity that you provision. And what this does is it really lowers the incremental cost of the compute that you're provisioning. A lot of times where I see a good example for right-sizing is when you're putting new workloads onto the AWS environment. So if you're unsure of what capacity you might need, you can run and test your instance, and then after getting some performance metrics, potentially change an instance on the fly. And this comes down to one of the value propositions of AWS is that you can make adjustments in the instances that you're running. Since there's no contracts and it's an on-demand resource, you can very easily change the instance size to meet what your requirements are tomorrow if they're different today. So you have that flexibility. I want to run through an example of how right-sizing works, in the real world, or what the cost implications of it will be. So as we said, if you migrate an instance in, we might start with an M4 4x large. And as an example, that particular instance in the Sydney region costs $1.72 per hour. We start here, and what I encourage customers to do is use a service called CloudWatch to measure and monitor the CPU, RAM, and network utilization of that particular instance. In this case, it's a little small, but I'll just highlight over here. Running this workload with the 4x large, this instance is running around 15% utilization. So in this case, we have an instance that's running kind of underutilized with overhead of $1.72 per hour. An example of where you can right-size that is downgrading that instance to an M4 large. And if the CPU, network, disk, and other infrastructure requirements are adequate, we can run that large, potentially in this example around 80% utilization, which still meets the requirements of your workload. Typically in this pattern, it'll be a step-by-step. So where you migrate or you run, you check, you right-size, you review, and then granted that the performance of the application is adequate, you let it run and you can benefit from savings. In this case, migrating from a 4x large to a large, which gives the same amount of capacity that we need for our application, but at a much cheaper rate. So 87% savings in this example. If you look through your environment, you might find examples of where you can do this and benefit from cost savings. In line with right sizing, typically I would encourage customers to look at decommissioning unused capacity or resources that were previously provisioned on the platform. So areas where you can get some quick wins are in areas such as the deletion of unattached EBS or elastic IPs. When you terminate an EC2 instance, depending on your configuration, that EBS volume might be left over and it might stay remaining. And if you don't delete it, you can incur costs. So if they're no longer used after you get rid of an instance, take a look and see if you can remove those unused resources. Same thing with idle or unused load balancers or incomplete S3 transfers. I'm going to give you a tool on the next slide, but a common area we can also look is just idle EC2 RDS and Redshift instances. So if they're running and they're not being actively used, you can look at deleting them or just turning them off. And I'll give you some tips in some further slides of how we can just turn instances off in an automated fashion. So the tools for how do we complete this first pillar? So how do we look at right-sizing instances and how do we look at getting rid of unused resources? Well, I mentioned CloudWatch. So CloudWatch is a monitoring and a management service. It helps you get actionable insights. So you pump information into it such as logs, events, or metrics from the resources that you're running. And then you can make actionable decisions on those insights. So in the case where I downgraded from a large instance to a small instance, that example and those insights were gathered out of CloudWatch. Another really important resource that you can take advantage of is the AWS Trusted Advisor. AWS Trusted Advisor is a part of business support, and what it does is it automates various checks across your account. It looks at a number of different areas such as availability and cost optimization of the applications that you're running. And in the cost optimization area, it'll check for things such as idle EC2 or idle EBS volumes, and it'll give you quick win recommendations. So if you have business support, I would certainly recommend taking a look at Trusted Advisor. You can run those checks and you can get a nice report that'll show you savings that you can have by just deleting some unused capacity. There's also a number of third-party tools in this area, so I mentioned I'd make recommendations there. So if you're looking for automation around right-sizing or capacity, certainly look at some of these providers that I'll mention. So Stacks, Cloudability, Cloud Health, and Datadog. They're all very good tools and can assist you within the right-sizing and cost optimization journey. So that wraps up the first pillar. So the second pillar that we look at in regards to cost optimization is increasing elasticity of the workloads that you run on the platform. So increasing elasticity, what that really maps to is more closely mapping the capacity that you have provisioned with the demand that your workloads have and as close to real time as possible. In this diagram or this example, we have a traditional IT capacity workload where we have fixed capacity provisioned. And in the new one, the cloud capacity, it's more dynamic. It goes up and down based on the workload requirements. I just want to give a good example of the cost implications of introducing elasticity in your environment. So again, that same principle where we had in this situation an M5 2x large, which is a static environment. Looking at this demand curve that goes up and down, that running 24/7 costs around $8,200 a month, and that's kind of a fixed infrastructure with no elasticity built into it. Changing the model and looking at smaller increments of compute. So this is achieved using an AWS feature called Auto Scaling, where we horizontally scale your application, effectively adding smaller nodes of compute, but still managing and meeting the capacity requirements that you have. So here in this example, where we're using this principle of auto scaling, we're scaling up M5 larges, which are a fourth of the size of the 2x large. And the cost consideration for running that for a month goes from $8,200 to $4,400. So this is a really cost-effective way to optimize your workloads, is use these smaller increments of compute and scale them out. If you haven't done this before, or if you're looking for guidance on how you make your applications friendly with auto scaling, one of the things that you can take advantage of is your AWS account management team and your associated solution architect. So we can really assist you in helping with these design principles and seeing if your applications are suitable for this type of scaling. In the same vein as auto scaling, you can also look at scheduling as a way to increase elasticity in your environment. So typically you'll have a production environment that you'll run 24/7, but for environments that are not production or are not needed 100% of the time, you can look at scheduling them on and off. A common use case where this is taken advantage is within development and test environments. So by scheduling your development test environments to turn off on the weekends and at business or outside of business hours, you can look at saving up to 70% on the associated compute cost. So this is a really effective way. If you want to get some quick wins, is utilize some tools, and I'll show you the tools in the next slide, just to turn things on and off. Because AWS is consumption-based, if it's turned off, you won't be charged, and you can turn it back on, and your capacity and your resource will be right there for you again to use once it's been turned back on. Excellent cost optimization mechanism. So you might be asking, how do you do that? So there's a number of different tools, and there's also documentation around this. So if you're looking at a guide to auto scaling, you can look at AWS, Amazon.com/documentation/auto scaling. You can see some information there. The same thing with the AWS Instance Scheduler. You can certainly check out that documentation and get assistance there. Again, there's third-party tools, so I always like to make recommendations to help with automation. These tools, Gorilla Stacks, Schedly, and Park My Cloud, certainly can help you if you're looking at third-party technologies to help manage some of that automation for you around elasticity and scheduling. So great tools that are available in the AWS ecosystem. The third pillar that I want to go through is the utilization of reserved instances. So if we look at a linear approach to cost optimization, I'd say the first one is making sure that you get your right sizing done and that you're meeting your capacity requirements. Second one is let's schedule things on and off so we don't have anything running when we don't need it running. And the third one is the utilization of reserved instances for production or mostly on workloads. A reserved instance effectively decreases your unit cost of compute. And what it is it's a commitment on your behalf, either 12 or 36 months. And for that commitment to a particular resource, you get a discount on the hourly rate of compute. Reserved instances are pretty unique, so it's not a one-to-one tie to a particular instance. So when you buy an RI, it doesn't match to one instance. You can think of it more as a coupon. And when you procure this coupon, what it does is it looks within your AWS environment and it looks for associated instances that have like characteristics. And it finds a like characteristic, it applies a discount or to the hourly rate. Because of that, they're just really a financial construct, or it's a billing mechanism. So they're flexible in how they're applied to instances on your account. To dive deeper into what those particular characteristics or metrics that you have to choose, there's four main ones, and I just want to run through. And if this anything sounds confusing, I'll show you how you can get an automated report out of your account that'll show you exactly what's the best recommendation for you. So the first thing that you choose when you are looking at a reserved instance is we look at a reservation on an instance type. So commonly you'll already have something running and you'll follow what you have running. So an example of an instance type or an instance family is an M4. Common other ones would be like C4s, C5s, M5s. These are all examples of instance families. The next thing that you choose is the operating system that you're running. So you'll choose whether or not you have Windows, Unix. You might be running some other flavors. You could have a Windows coupled with SQL Server. These are all options that you'll have to define within your RI. You then have the choice of the region, and if you specify the particular availability zone that you want, and whether or not you want your instance to be shared or a dedicated host. Now again, a lot of these things will be predetermined by what you have running today, so you can just look at the report and see what the recommendation is, and it'll help you. The value of these reserved instances is really the discount that you get over time on these commits. So for a 3-year or a 36-month term commit on a particular resource, you can have up to a 75% savings. Typically what we see on a 1-year or a 12-month term reserved instance is 20 to 40% savings. So it's a very efficient way once you have a baseline requirement for compute to cost optimize if you can give that 12 or 36-month term commitment. So there's a number of different services that reserved instances cover. So they not only cover EC2, but they also cover RDS, Redshift, Elasticache, and Elasticsearch if you want to buy RIs. And then in addition to those two, but which are not really reserved instances, but they are commitments that you can get, is you can get commitment discounts on DynamoDB and CloudFront. So if you're looking for if you're running any of these services, I'd recommend just checking out what you can do in regards to commit and how you can lower your unit costs on consumption. So just a few slides on the details in the reserved instances to enable you if you want to look at these in further. As I mentioned, they're available in 12 and 36-month terms. They're also available in 2 different flavors. So the standard reserved instance is I'd say the traditional RI that we offered, and it was the commit on those characteristics that I previously mentioned: the tenancy, the family, the operating system, and the region. We recently, in the last year to 18 months, have offered customers the option around convertible reserved instances. I'll give you some details on easily how these work. Effectively, they allow you to convert and change things within your term commit during that 12 or 36 months. A couple of factors that you have to look at is how you buy these reserved instances, and this adds flexibility into your procurement model. So whether or not you want to pay no upfront, if you do a no upfront reserved instance, effectively you're just lowering the monthly cost of that instance over that term. But you can also elect to pay a part of that reservation up front, or if you'd like to decrease your monthly cost down to 0 and then have a full upfront cost, you can also pay full upfront for the compute that you're provisioning. As I mentioned, there's the operating system, the instance type, and the tenancy. And the reason I call out these ones in orange is the boxes in orange affect the level of discount that you'll get. So there's a bit of a spread. I just wanted to give you some information on what that spread looks like and where maximum discounts are applied. So the greatest discounts in regards to payment options goes left to right, with all up front being the largest discounts that you can procure. 3 years. I'll go into how you can make adjustments in the 3 years with the convertibles. Typically, the largest savings you'll see is on Linux. Instance type is an interesting one. In addition to running reserved instance and getting the largest discount on the newest generations, you'll also find that the latest generations of compute available on the AWS platform typically are cheaper on demand as well. So if you're looking at a quick win optimization mechanism and you've been running a workload for say 2, maybe 3 years, and it's running on a version that is a little older, so for example, a C3 versus the new C5s, you can explore moving to the latest generation of AWS instances. Previously, as I mentioned with the flywheel effect, as the platform grows and incremental cost goes down, typically that's where we'll see savings in those newer instances because the incremental cost of them is cheaper. So check out new instance generations if you're looking for a quick win. But back to the reserved instances, standard RIs typically offer a few percentage more in regards to savings than convertible. So I want to spend a minute diving into the convertible reserved instances. So convertible reserved instances were requested quite a bit through our customers, and per customer feedback, we released them to the market. And customers were looking for a couple of key things that when they had RIs. They were looking to take advantage of new instances. So with the standards, you can't move between, for example, an M4 and M5. So convertibles allow you to do that. They allow you to change your reserved instances as business requirements change. So if you want to change what kind of compute you're running. Therefore, drastically reducing the likelihood of any unused reserved instance. And they also allow you to take advantage of price drops. So if we drop price on compute, within the convertibles, you can take advantage of that. How you're able to obtain these benefits is that instances that are convertible allow you to change the family. So for example, an M4 to a C5 or to the latest generation. You can also change sizes. So if you have an operating system with an associated licensing cost, under the convertibles, you can change it. So moving from a large to an X large, or you can even go down from an X large to a large. We can change operating systems, and last, we can change tenancy. So these things are not available to be changed within the standard reserved instance offering. So convertibles give that flexibility. Just to run through what you're committing to on a convertible reserved instance, you're looking at a 1 or a 3 year term. You're committing to a region. Currently, they're available only on EC2, and you're converting to a spend, committing to a spend. So just to give you some examples of how that spend commitment works, if you're looking at potentially moving to a smaller instance in the future, convertible reserved instances will allow you to do that. So you can split, for example, an M4 X large into 2 M4 larges. How that works is we look at the upfront cost of the convertible reserved instance at the time of your procurement, and we compare it to the new upfront cost of these two. And if there's a delta, you're charged a true up. In this case, no true up cost. Here's an example of where there is a true up cost, and that's from going from an X large to a 2X large on the M4 family. So we compare the $20 upfront to the $40 upfront, and we have a $20 delta. Two just quick more examples of potentially moving to a new or more expensive instance. So in this case, adding an associated licensing cost. So if you want to move to Windows to Linux, you have a $5 upfront, therefore $5 true up. Or even if you want to split instances apart and move to different families. So in this case, moving from R4s and spreading that across T2 larges, you have that capability. In this case, we just take the 25 upfront and compare it to our new upfront cost with a true up cost. So that's really where the power comes in around convertible reserved instances and the flexibility to make adjustments. One thing to note is that if you do have convertibles, or if you're looking at standard reserved instances, so this is offered for both, is that both of them, if they're regional Linux and shared tenancy, they can still scale up and down within a particular family and instance. So for example, if you have an M4X large, you can scale that to 2 M4 larges, or the inverse, half of an M4 2X large. So instance size flexibility is available for both standard and convertible, as long as you're within those characteristics, the regional, Linux, and shared. So you might be asking, where or how do I get information on procuring RIs, or how do I make the analysis? And this goes back to the Cost Explorer mechanism I described earlier. So within Cost Explorer, one of the pre-built dashboards is your ability to see the RI coverage of your account. And we define that coverage effectively on what percentage is running reserved versus what percentage is running on demand. As a mechanism in your organization, I would look at what percentage is best for you. So whether it's 80%, it's 50%, it's 20%. In our discussion later with Paul, we can ask him his opinion on this. But effectively, everyone will have a different coverage model. And then you just set a target around what your coverage model is. In order to get coverage, then also you need to potentially reserve or commit to reserved instances. And AWS recently has built out capabilities to help you do that. So within the Cost Explorer, you can click on the #1 step in your menu bar and go to item 2, and it'll show you AWS RI recommendations. So you can look for EC2 RDS. And what this new report will do is analyze historical data within your account. So based on 7, 30, or 60 days that you configure, and it'll tell you what instances that we suggest to make reservations on. It also gives you the ability to choose the term, the offering class, and the payment option. So as I mentioned, those are all things that will adjust the rate of savings that you get. If we go back, the highest saving was a 3-year standard all up front. But you can mix and match these, and then you can see what the savings will be for your particular AWS account and for the instances that you have running. So in this case, by choosing these criteria, I can see that the system has made a recommendation for 38 T2 nanos. I can see the upfront cost of those, then what my recurring cost is, and then my monthly savings. There's some more down here that are removed, but if I were to add up all of the instances that in this recommendation, I would save 34% on running within reserved instances versus running on demand, which throws up to $1,700 over the year. So pretty material savings for making this commitment. Once you've bought reserved instances, it's then really good practice to monitor them on a normal basis to make sure that your investment is being maximized and used. And again, you can go into your Cost Explorer and use a pre-canned report under RI utilization and see what the utilization of an instance is. So I built up in his example what typically could be I would call a poor utilization, around 40 to 20% here. Typically what you want to do is have 100% utilization, therefore maximizing the commit or the investment that you've made in a particular instance. At the bottom here, you'll see how many RI hours that you've purchased, how many are used, and then how many are unused. Typically, you can use this report to make adjustments. So if you're running a convertible instance, you could find a RI that is underutilized and then convert that to something that will be fully utilized. You can also set up automated ways to let you know of low utilization, low coverage, or spend increasing. So you don't consistently need to log into the billing console or the Cost Explorer, and you can do that through AWS budgets. So AWS budgets, you can set up triggers based on certain metrics, and you can get notifications on these features. So if you are looking at RIs, or if you want to set measures around your spend, feel free to jump into your console and check out those mechanisms to set up some automation around the different reports that I just went to in the last couple slides. So those wrap up the 3 pillars around compute, which was right sizing, elasticity, and reserved instances. I want to quickly touch on the last two, which were storage and building for optimization. So in the storage, some quick wins that you can look at is just matching the EBS volumes that you procure with what your workloads require. By default, when you look at EBS volumes on the platform, they are general purpose or GP2s. And that's typically what most people will choose, as it's a very good general purpose disk. However, if you have workloads that can use different drives, I'd recommend taking a look at your throughput optimized hard drives or even cold hard drives. And using these, you can save approximately 50 to 75%. So if your IOPS for your workload are sufficient to use these different drives, it could be a good cost saving mechanism for you. Also remember that size for EBS matters. You pay for, unlike EFS and S3 that scale up dynamically based on what you put in, with EBS, everything that you procure, you pay for. So if you provision a 1 terabyte drive and only use 100 gigs of that drive, you're still paying for that full disk. So just make sure you match as close as you can in regards to what you provision versus what you need. In the same vein around provisioning storage, just wanted to give you some quick tips on S3. So S3 has multiple different tiers with the introduction of infrequent access and Glacier. So by default, objects are stored within S3 standard. If you have objects that are infrequently accessed, or if you have backups or long-term storage, I'd recommend taking a look at infrequent access and Glacier. Glacier is around 1/4 of the cost of S3 standard. So if objects don't need to be readily retrieved and they're being stored from a backup or a compliance or regulatory reason, Amazon Glacier can be an excellent mechanism for you to save on those object level costs in your S3 buckets. The last pillar, and this is an area where you can work with your account management team and with the AWS solution architecture team, is designing for cost. So we've made a number of improvements to the platform, and we're continuously releasing additional services. And a lot of new services that are being released are focused around serverless. And serverless, particularly the use of AWS Lambda, can be an excellent cost mechanism for how you design future workloads. If you're unfamiliar, AWS Lambda is a compute mechanism where you can run code and effectively pay for that code for the time and execution of that code, opposed to paying for infrastructure and servers associated with running that application or that code. So it's a very cost-effective way to run code. You can also look at taking advantage of AWS EC2 Spot. So this is the ability to provision and procure unused capacity on the AWS platform in a bidding mechanism. So you bid for the capacity, and if your bid exceeds the rate, then that capacity is available to you. I've seen examples of where EC2 Spot can be up to 1/10 of the price of the on-demand per hour EC2 cost. So excellent way to cost optimize if your workloads can be utilize Spot. There's a number of different buckets here, and these are all areas that the solution architecture can work with you on through our best practices in our solution whiteboarding session. Just to call out one last one, always happy to help assist in how you can leverage open source platforms and databases. So AWS is a very friendly ecosystem in regards to open source. You look at running Postgres or, for example, Linux, if you want to look at how you can decrease licensing costs. Those are just the ones that I'll call out. But many different mechanisms that you can look at from your design phase all the way to building and running your applications. So to summarize, as they go left to right, you can look at right sizing, you can look at the elasticity, and then after you've done your baseline and your compute requirements, the reservations, and last, designing for cost and matching your storage requirements. I just have 3 more slides, and then I want to jump in with Paul. And just want to highlight that most organizations approach cost optimization as a cyclical manner. So you'll look at, as workloads grow, establishing visibility. Once you have that visibility, then how can you look at architectural optimization, such as right sizing or scaling? How you put mechanisms in place, such as monitoring with budgets or with Cost Explorer, and then pull out quick wins, potentially from Trusted Advisor or CloudWatch, to see how you can just enable those as fast as you can. There are a lot of different resources that are available. So just to summarize in here, I'd highly recommend checking out YouTube. We run different sessions, particularly around reInvent, around cost optimization. So if you check out our channel, you'll see a number of different things there. And the last one, to establish really good visibility, a common overlooked area is tagging resources. So if you want, you can look at some additional information on tagging, but tagging effectively is a mechanism to help you establish a link between either application, business unit, or application owner and the cost. So it's a good mechanism to bucket costs associated with the criteria that you have. So that summarizes where I wanted to go today around the realizing value in the cost. Now where I want to go is talking with Paul. And Paul, you've been really patient waiting here. I just want to say hello. Maybe you can do a quick introduction about yourself.
Sure. I'm from Fairfax Media. I'm officially a systems architect. Been working at Fairfax for about 10 years now. And Fairfax has been using AWS since 2012, before it was even in Australia. We've been enterprise customers since about late 2013, and we've gone through quite a few of those cycles of visibility and cost optimization over the years. In the last couple of years is when I've been really focused on cost optimization, and that's the prime part of my job now.
Yeah, and I want to say thanks for coming in today. The reason we wanted to ask you to come in is because I think over that journey you've learned a lot about cost optimization and that pattern of establishing the visibility, and to get your viewpoint on how it all works. So I'm curious around cost optimization and particularly your practice, and what does it look like in a day-to-day being a cost architect from Fairfax?
Sure. So most of the announcements for new AWS products are done during business hours in the US, which is overnight for us here in Australia. So the first thing I do when I get up is check all the official blogs, checking Jeff Barr's Twitter feed. I'm not really looking for anything anything interesting at all, but anything to do with cost optimization. For example, new instances, which are, as you were saying earlier, more performance, but also are much more cost effective for us. So whether we can think about whether we have existing RIs that we need to allow to expire so we can allow new ones to come on, or whether we need to start migrating onto new instance types. Or it may be something smaller. It might be a new part of an existing service. S3 Select was quite a big thing for us. So rather than having to pull a large amount of data out of S3, we can now construct queries and just pull subset outs, and that's a lot more cost efficient for us. So looking for any kind of cost optimization levers from AWS that we can use, anything that's new. And then after that, going on to third-party blog sites, going through some newsletters. I use Medium quite a lot, having searched through Medium for AWS articles. Corey Quinn's last week in AWS newsletter, and a few others of a similar nature. And I'm really looking for any kind of cost-related articles, architecture-related as well, any new tools that could be worth evaluating, and anything that will help me to reduce cost for Fairfax.
So there's a lot of information in the industry that you're ingesting through mechanisms like social feeds and blogs. Coming back a little bit more to the AWS team locally here in Sydney, you work with the enterprise support and with your account management team. How do they support you in regards to cost optimization?
That's right. We have enterprise support with Fairfax, and we have a full technical account manager team, a solution architect team as well. So we're given access under NDA to some roadmap items, and that can be very helpful to us to plan well in advance to be able to test new products and see whether we should use them, whether we should migrate to them. A fairly recent example was around Aurora Serverless, which allows us to scale down our MySQL databases when they're outside of usage, or when they're in idle time. And that's a really fantastic way, particularly for non-production environments, for us to be able to scale everything down to a very low level overnight, for example, or at weekends. And that has a massive impact on our bills. So that kind of access through our enterprise support team to previews and betas and roadmap items is really, really valuable.
Yeah, and for everybody online, I think it's important. So you have enterprise support, but anyone who doesn't, they can always engage with their account management team, and you can engage. For example, I'm an account manager here in Sydney, and we have a solution architect, which is my counterpart, that you can always get the same mechanisms and assistance that Paul does in regards to roadmap and help. So it's a good mechanism. So specifying it even further than and going in line with what we talked around cost optimization, how do you keep an eye on your costs? I'm sure that within Fairfax you have lots of units and many different AWS accounts. How do you keep the focus there?
Yes, we have a consolidated account. We have a master payer and lots of sub accounts kind of broken down on business unit levels. I use Cost Explorer for that. I also use budgets. So if there's a larger unexpected swing, I would get a proactive alert through AWS budgets telling me that there's been a big upswing in my costs, either overall or for an individual account. But that's pretty rare, to be honest. So it's more often that I'm going into Cost Explorer and I'm looking at the previous day's costs and what the estimated costs are for the end of the month. Just looking for kind of smaller swings. Maybe there might be no overall increase, but maybe my S3 costs in a particular account have gone up slightly more than expected, and it's better to try and catch that thing early than to let it go towards the end of the month and get some unexpected costs. Mm-hmm. So that's the next thing I'll do. And then I go on to kind of other alerts where Fairfax is a very heavily automated infrastructure. We use tools such as CloudFormation and Terraform a lot. So it's very rare for us to have untagged resources. So if anything does come up, I get notifications for those. So I want to make sure that all of my resources are appropriately tagged with a business unit name and an application name. So there's no unassigned costs at the end of the month. So if anything does come up, I want to make sure that's tagged and remediated as quickly as possible.
So it sounds like you have a good rigor around your daily mechanisms for looking at your monthly. How does that play out in, for example, a quarterly or longer term? Do you have any things that you establish or look at every quarter?
Sure. We have, as part of our enterprise support, we have regular meetings with our AWS account team. They produce a report for us, and that's looking at more long-term trends. So we can look by month to month of things like storage and networking, and then you can see things that pop out a lot more then than we do when you're looking at like daily or monthly costs. A couple of examples: we've had some S3 buckets which were slowly creeping up over a period of time. Not so easy to spot on a monthly basis, but when you're looking at a 3-month or 6-month even window, you can see that it's quite a significant amount of growth, and that was something that we were able to cut off quite quickly. Another example would be network bandwidth costs. We get a report from our technical account manager, again showing all of our accounts different network costs, and we could see some kind of odd behavior that when we dug into a little bit more, we realized was an application migration. It was moving from one account to another account, and as part of that we had to ingest a large amount of data, and that came up as a large network spike. So that really helps us. Those reports really allow us to dig into those longer term trends. I also, on a regular quarterly basis, arrange for workshops and brown bags for staff within Fairfax. These can be on cost optimization or non-cost optimization features from AWS. Some of them I present, some of them are presented by AWS solution architects and our account manager team. The most recent one was on a deep dive on Spot instances, which was fantastic as a way for us to get much more detail on that. We've been using Spot for quite a while, but it's a very wide product. There are lots of details to it. To be able to really dig into it was incredibly useful for us. And finally, I look at the tools marketplace. I look at both the big three cost SaaS tools, the Cloud Checker, Cloudability, Cloud Health, see what they're up to, what new features they have, and whether we use one of those at the moment within Fairfax. But I'm always looking to see whether the competition have come up with something that makes it compelling for me to move over to them, and also whether there are any new tools that I can use. A couple that Fairfax are evaluating at the moment are Gorilla Stack, which you mentioned earlier is a great automation framework, and also Cloud Conformity, who have a more security focused tool but have cost optimization options in there as well. So anything that comes up new on the tool marketplace, I'm really interested in to see whether it can help us.
So it's around that establishment of visibility, and once you have the visibility, how do you monitor it over time?
That's right, yeah.
And then, when you have that visibility set up, I'm interested on the quarterly or the monthly basis, then how does that play into your reserved instance analysis?
Yep, so I keep an eye always on the expiry dates of all our reserved instances. We tend to go with yearly reservations. Each of the accounts or the business owners buy their own reservations in their own accounts, but I help them by getting reports out showing what running instances they have. And I go to all the stakeholders and say, here's what you have reserved at the moment, what's expiring. Does that application that's using those instances, does it have a long-term future? Is there any scope to maybe go from a C4 to a C5, or can we scale it down? Anything that's, any kind of changes that we can make before we go and renew those reservations. I always target, you said what kind of percentage to target. We target 80% for RI coverage. We'd like to push it higher, but ironically, we actually have a business unit in New Zealand which is running 90% of their production workloads on Spot, which is kind of dragging down our overall target. But yeah, obviously overall it's better for us from a cost point of view. And also then I'm very interested in any kind of new projects we have coming along that maybe need us to purchase some more reservations for that. And on the flip side of that, whether there are any applications that we can migrate into serverless technologies, so the requirement for those RIs just goes away.
Mm-hmm. I see that. So you mentioned you established the 80%, and then it's typically an annual evaluation process. I think that's a pretty common benchmark. Mm-hmm. The 80% is a very good threshold, but if you're looking internally in your organization, just for anyone to call recommendations around how often do I look at these, I think it's annually every 6 months for major.
About every 3 months.
Oh, 3 months. Yeah.
Some business units are even more frequent than that. Some of the heavier users are interested in doing monthly reviews of whether they can expand their fleet of RIs.
And so you mentioned the different business units. Obviously, that plays into a large organization. How do you do cost optimization across a large organization with multiple business units?
Yes, so we do have a consolidated account, so that allows us to get those economies of scale around some of the volume-based services that AWS produces, but also gives us the granularity of being able to have separate invoices per business unit or per stakeholder, which is a fantastic thing for us. I guess the other thing within a large organization is that you're always having reorganizations, mergers, acquisitions, splits. So there can be a degree of retagging of resources or maybe migrating resources between accounts that is required as well.
Yeah, I think it's a common pattern that when you start breaking things apart to look at those multiple different accounts, and then as we mentioned, like the tagging, it's a crucial component. So I just want to wrap it up with one last question. Just what are the three most important factors that improve your agility and help you move fast in your role?
Sure. There's three main tenets that I think are really important around cost optimization. The first is having team visibility of costs. It's no use having the costs of the bills come in and nobody is really aware of what's going on. You need to be sure that everyone who's a stakeholder in your AWS infrastructure has visibility of the costs, whether it's dashboards in the office, whether it's being spoken about in team meetings, in your town halls, in your sprint planning. People need to have an idea of costs, and they need to have cost as part of their focus. When they're deploying things, they need to think, what's the most cost-effective way that I can deploy this? So the first thing is getting that real visibility of costs, so there's no surprises at the end of the month. The second thing is around tagging. You mentioned earlier on about tagging resources. I think that's absolutely critical. It's certainly something within Fairfax that is heavily mandated. You need to be able to tie a running resource from your bill all the way through to a single line item and something that you can see in the console. So we have a very strict tagging standard. It's been developed over several years so that things are tagged with a business unit, an application name, and even an environment. So you can say, well, everything that makes up my UAT environment for this particular application, here are the exact costs. And it's really great for finance people that they can see all these line items with tags assigned to them. And the last one would be automation. So it can be very easy to just provision infrastructure and then just not come back to it. It needs to be maintained. It needs to be automated. Things need to be, as you mentioned earlier, turned off outside of hours, like development environments. You need to have your auto scaling working, and it's really about making the most cost-effective use of your infrastructure by not allowing it to remain static. Now, all three of these things, the visibility, the dashboards, the tagging, the automation, there is a bit of upfront effort involved, but it really does become well worthwhile when you see that your bills are reducing on a month-by-month basis. And this is something that AWS can help you with throughout your journey.
Yeah. So that wraps things up. Thank you very much, Paul, for the information. I think we're almost right on time. I'll leave it with just two last comments. If you're looking for assistance within cost optimization, please reach out to your account management team, and we can engage with the solution architecture team as well to help around those principles that we mentioned. And then the last one, just as I'm going to wrap up now, if you please stay online. Feedback is very important to the AWS process around how we do services and particularly content. So if you could please answer the 3-question questionnaire, it'll help us in future content. Again, thank you, Paul, for joining us very much, and thanks to the team for helping facilitate. And with that, I'll let everybody answer the questions and just say thank you myself. Cheers, everyone.